Okay, what's the solution to the system? Use a graph. You're essentially being asked to graph these lines to see where they cross. And if you want to graph these, you need to write them into a form that you know how to graph. So what's the form that you know how to graph? Well, I think most kids are comfortable with, I'm going to write it up here on top, slope-intercept form, which is y equals mx plus b. Sorry about that. I have controls that you can't see, and I'm trying to avoid them when I write. Okay, so let's solve this for this first one. 5x plus 4y equals 9. The first thing that I want to do is I want to get everything that's not one of the y's off of that side. Okay, so how do I do that? I subtract the 5x away from both sides. And what do I get? I get 4y is equal to negative 5x plus 9. Okay? And then I want to divide both sides by 4. Everything that's separated by a plus or minus gets divided by 4, so that it just says y equals. Now you'll see negative 5/4 x, that's not a problem. You know how to graph fractional slopes, but what's a little bit more tricky maybe for you is the fractional y-intercept. Okay, that's not a whole number. That means it's going to be somewhere, if you know how to convert this fraction into a mixed number, you say how many times is 4 going to 9? 4 goes into 9 twice. 4 times 2 is 8. If you take 8 away from that 9, you get 1 left, and they're fourths. So that looks like this. Okay? And not a problem, but, and I'm going to actually erase the work and I'm going to write this up top. But that might be a little bit trickier for you to graph, in which case I will show you what the other one is when you isolate y and write it into slope-intercept form. And you can see that that one's actually an easier one to graph. And so we can first check for any answers that don't have that line and eliminate them as possible options. So just give me a second to erase this and move it up. Okay, and just to be clear, I'm going to underline the equation in pink that I just solved for and is written in pink right there. Okay, now I will do this one in blue and solve that one. Okay, 4x plus 4y equals 8. Now, if I want to solve for a y, first thing I need to do is get everything that's not part of the y's off of that side. So I'm going to subtract away those 4x's, and I get 4y equals negative 4x plus 8. Now when I divide everything by 4, which is the coefficient of y, so it just reads a single y, and what I get is y equals negative 4 divided by 4 is negative 1. And I don't write negative 1x, I just write negative x. And then 8 divided by 4 is 2. So that is that second equation. Let me erase that and move it up. Okay, so you can see that these two lines both have negative slopes. And what does that mean? That means that the lines will be doing this on the graph. They'll be dropping as you go to the right. Okay? And they both have a y-intercept of, one of them, the blue one, has a y-intercept at exactly 2, and the pink one has one at just above 2, 2.25. Okay? So we're looking for one of the graphs that has two lines with negative slopes, and that already straight away will eliminate this one. They're both positive slopes, and this one, both positive slopes. And we need the two lines to be crossing the y-axis at, one of them crosses at 2, one of them crosses at a little above 2. And you can see that that eliminates C because those are below the x-axis, which means that the y-intercepts are negative. Okay? So here we have the two lines, one that crosses at 2, one that crosses at just above 2, and they both have negative slopes. Pretty good. Are we done? Well, yeah, you are in a certain sense because you know which one it is, but we're going to go one further here before we're done, and we're going to just test these points out. Okay, we're going to take the original equations. Don't ever substitute into your modified equation because if you made a mistake, then you won't know that it won't appear unless you use the original equation. Okay, so we write the first one, and we put parentheses there wherever we see the variable. And as you can see, the solution over here, watch my laser pointer in the pink box, is at 1, 1. So we're substituting in 1 for x, 1 for y. And when we do that, we get 5 plus 4 equals 9, checks out. Okay? And let's do it one more time with the other equation. 4x plus 4y equals 8. And wherever we see a variable, we put parentheses. And we substitute the values in, 1 for x, 1 for y. And we get 4 plus 4 equals 8, or 8 equals 8. And it checks out. So we know that D is the answer. Do you have to do all of that work? Nope, you don't. I like to be thorough, though. I'm a math guy. I like to be sure about what I'm doing, check my answers, go the whole way. If you want to have excellence in math and you want to go far in math, and for many folks, they have an idea of what they want to be when they get out of college, what they want to take in college and then as an adult. For example, my wife, since she's 12, she knew that she wanted to be an architect because her parents would buy houses and then they would remodel them, and she just really got the bug for that. And she's like, I want to do this. But just the fact that if you want to be an architect, you need to do math. You need to know math. So she committed herself to math early on, knowing that she had a goal and knowing that her goal required her to know that. So if you want to have excellence, then don't shortcut every chance you get. Do your proofs, be thorough, be sure what you're doing. Sloppiness is not something that you want to see in architects or engineers building buildings and bridges and such. So many jobs require it, and if you're strong in math, you will have so many options in life. And I'm certainly glad that I stuck with math. It's really paid off for me, and I love it. I have a lot of fun with it, and you always have fun with math when you kind of get it and you get into a rhythm with it and you know rules and you can apply them correctly. When you can't do that, then it seems like a struggle. But if you struggle now, just know that if you commit yourself to it, then you're going to have a better experience. It's going to just be much more pleasurable, and you'll find yourself going far because you spent the time to master it in a way that allowed it to be a positive experience for you. So that's my little pep talk. But do the work, do the proofs. If you have time, especially on the final, and you have some time left over, take the answers, plug them into the equations, see that they actually work. If you have a way of verifying your answer, and you don't when there was time left over, and then you get that one wrong, what a shame, because you could have gotten that right if you had just checked it and discovered that you had an error. So be thorough.